In this video, we're going to see how we can subtract rational numbers. And this is going to be very similar to how we simplify when we're adding. The only difference is we're going to have to make sure we pay attention to this minus and that we fully distribute it once we get to that point. So the first thing that we're going to do is we're going to find our common denominator. And we do that by factoring both the denominators. So x squared plus 12x plus 27, I'm looking for a pair of numbers that multiplies to 27 and adds to 12. X plus 9 and x plus 3. 3 plus 9 is 12. 3 times 9 or 9 times 3 is 27. The second one, x squared minus 81, this is one of those special patterns. This is a difference of squares. X squared and 81 are both perfect squares. So we use our difference of squares pattern. X minus 9, x plus 9. It doesn't matter which one has the minus, which one has the plus, so long as you have two factors with x and 9 and one having subtraction, one having addition. So now that we have it in factored form, we look for what is common in both of them. Well, I see x plus 9 in both. We take the factor that is not shared, and we add it to the opposite one. So here, x plus 3 is in my first one. I need to put it at the end of this second one. And x minus 9, the first one doesn't have an x minus 9. So I put it attached to that one. And now we know if we multiply our denominators by a certain value, you need to multiply the numerators. So for this first fraction, I need to multiply the numerator by x minus 9. Right? And I like to put parentheses around the whole expression so that I know I need to fully distribute. For the second one, we're going to multiply by that x plus 3. All right, so now I can rewrite the problem. I'm going to write it as 4x plus 1, x minus 9, x minus 5, x plus 3. All right, and all over. Again, the order here is not going to matter since they're being multiplied, but you need to make sure all three of those factors end up in your denominator. As we have it here, this is left in its fully factored form, but I want to try and simplify it, at least in part. So we can multiply this binomial by this binomial. You could use the tabular method, you could use FOIL, you could use distribution, whichever method you are personally comfortable with is okay. I'm going to FOIL it. So 4 times x, or 4x times x, 4x squared. 4x times negative 9 is negative 36x. 1 times x, negative x. 1 times negative 9, negative 9. All right, so that's that first piece. I'm going to have to sort of squeeze in some values here. Minus, and then the second half of the problem. And I put parentheses around it because I want to make sure that I don't forget that I need to fully distribute this minus sign at the end. So 6x times x, 6x squared. 6x times 3, 18x. Negative 5 times x, 5x. And negative 5 times 3, negative 15. Once I have this, I can start to look for my like terms. All right, I have 4x squared And 6x squared, we need to remember we're minusing. 4x squared minus 6x squared is negative 2x squared. Cross those out just so that I know I've done them. Negative 36x plus x plus 18x and negative 5x over here. So we have negative 36 plus 1. And then again, we need to make sure we are distributing that minus. So minus 18 and then minus a negative 5 or add 5, whichever one you're more comfortable doing. And that gets me a negative 48x. All right, so that again, I know that's a long one, negative 36 plus 1 minus 18 minus negative 5. And again, you should get negative 48x. All right, and that leaves me with negative 9 and negative 15. Negative 9 minus negative 15 is a positive 6. And then we put the whole thing, again, you're not going to be asked to multiply 3 terms or 3 binomials. We are able to leave our denominator in its factored form. But that would be the simplified answer for the problem at the top of the page. Negative 2x squared minus 48x plus 6 all over x plus 9, x plus times x plus 3 times x minus 9.